What is in fact thermodynamics? Thermodynamics is as therm mean heat. So it is a branch of physics that deals with heat and energy and conversion between the two. If you have heat, you can convert it into energy and useful work, or if you have a work, you can convert it into the heat. So interaction between the two. Engineers need to understand the thermodynamics to solve various range of problems ranging from nuclear power plant, in the rockets, electrical equipments, jet engines, and in the steam engines. Because you can see in the, for example, in the steam engines, we burn the coal, converted into the steam, then ultimately it converted into mechanical form means train starts to move. So if we have a good knowledge of thermodynamics enables us to answer these questions. Just take an example to understand. For example, if you rub your hands for 15 minutes, what are you doing? You are doing work. So what will happen ultimately? Your hands warm up. So this is thermal energy you have generated by doing some works. So as I mentioned you, the thermodynamics, it deals with heat energy and its interaction with work, or work is its interaction with the energy. So this is a classical example of thermodynamics. Now try to understand thermodynamics much better by using some daily life examples. For example, here you can see this is a water kettle, and we use it to warm up the water, and it takes this initial energy from electric current. So electric energy comes to and converted into the heat. So again, normally when we deal with thermodynamics, we say electrical energy in terms of electric work done. So electric work done is converted into the heat to raise the water temperature. Let's take another example. This is the, you can say, jet engine in which we burn the fuel. When we burn the fuel, heat is generated and very hot gases are formed. Then these hot gases are propelled back at very high velocities, and as a result, a thrust is produced, and you can say aeroplanes start to move forward, and using that energy, we can fly in the air. Again, you can notice that thermal energy is converted into some useful work. Let's take another example. We have air conditioning at our homes. The purpose is to cool the whole room when you can say outside temperature is very high, or in other words, to warm the room when outside temperature is very low. So air conditioning, the target of air conditioning. Again, you can see we use input electrical energy, electric current or electric work is required, and we can convert it into some thermal form. For example, to heat up the room or cool down the room. So again, interaction between work and energy. Next example, we want to reduce the temperature of water bottles that we want to drink. What we do, we put them in the refrigerator, and what refrigerator does for us, it takes the heat out of the water bottle and throw it outside. So as a result, it will cool down. Again, you can see there is in the refrigerator there is a compressor. Compressor needs electric current. So initially, electrical work is coming and reduce, and we are able to reduce the temperature of the water. So again, thermal energy and work interaction is there. So being a engineer, what will be our target? We don't just understand the phenomena. We also want that the smallest amount of electrical energy is required to fulfill the task. We don't want waste extra amount of energy. So this is where our good understanding of thermodynamics will help us. As in case of jet engines, we can see that we want to burn minimum fuel so we can get maximum thrust. So again, we want to save the fuel and get the maximum energy. Let's take another example. We burn the coal to generate the power or electricity. Again, when we burn the coal, it means we are generating thermal energy. Then there is a lot of, you can say, internal equipment is there where that heat energy which is generated by burning the coal is transferred to the water or some other mediums with the help of heat exchangers. Then temperature is there, it might be turned into steam, high pressure. Then high pressure is used to run the turbines. Turbines will then run the generator, and ultimately generator will generate electricity for you. So again, thermal energy is converted into the electricity. Another example is car engines. We know we burn the fuel in the car engine. For example, if you know that inside the car engine there is a sorry, it should write better here. There is a car engine. This is the piston, and in the pistons under system, and it is connected to crankshaft. So when we burn the fuel here, high pressure gas is generated. That high pressure gas tends to move this piston up and down. So mechanical work is obtained. So when it moves up and down, so it is related connected to some crankshaft, and that crankshaft ultimately rotates, and that crankshaft is then connected to the, you can say, wheel some by mechanism. So thermal energy is then converted into the mechanical form of energy. Again, if we have a good understanding of thermodynamics, then we can answer these questions. So here target is that what's the largest amount of energy that can be produced by burning the minimum fuel. And if we have good understanding of our thermodynamics, we can answer many of these questions. So next, this is very interesting example. It is not by burning something, but again, it is related to solar energy. In fact, in modern time, we want to avoid the pollution. We don't want fossil fuels to burn because it causes pollution. So what alternate? Alternate is clean energy, renewable energy, not causing any pollution, coming from sun, coming from millions of years ago. Can we use that thermal energy? Yes. As you can see here, that this energy is coming from sun, and we need to collect it. So what we do, we design solar panels. So these solar panels are collecting the energy. So when this energy is collected, now we need, what is the target particular example? We want to collect the solar energy and want to warm up the water, and then ultimately use that water in the shower so we can enjoy hot water. So again, you can see here that hot water is coming down, and a pump is there. Pump is required because pump is to maintain the flow of the water. Then it goes into the heat exchanger where it is interact with cold water, and cold water is then become hot. Then we can use this cold water here. Then this hot water, which is now cold because energy is transferred to the cold water, is taken back to the solar panel. So this is all scheme which we used here. So again, heat energy is taken from the sun, and it is now it is used to make the water hot, and then we using it in the shower. So we in the kitchen, you can say we can also use it in the kitchen and anywhere, depending upon the number of persons at home. Again, we know we want to design a solar system, solar panels, but for how many persons? For how many people in one room? For 4 persons. So what should be the size of solar panel? Because we don't want to purchase or spend extra money on extra large solar panels. So if we have good knowledge of thermodynamics, how much energy is coming from the, for example, from the sun, and then what should be the size, this amount of energy is sufficient to make you can say to make water hot and take a shower for 4 persons average per day. So this is the target. So again, if we have good knowledge of thermodynamics, we can manage that. So what is next? Now we talk about more general terms, because thermodynamics is not just related to some general phenomena, but when we study, we will see many properties. For example, here we know pressure is a thermodynamic property, temperature is a thermodynamic property, density is a thermodynamic properties. If we know these properties, we can answer very good phenomena in daily life. For example, we know that water boils at 100 degrees centigrade. Can water boil at 50 degrees centigrade? Can water boil at 120 degrees centigrade? We can understand this phenomena very well, and we can give answers, yes, it is possible or not possible, if we have good knowledge of thermodynamics. Again, we know in the cold season, there is a, you can say, fog which is spread on the windscreens. What is the reason behind it, and how can we avoid it? Our knowledge of thermodynamics can help us. There is another example. Third, we know balloons, those are filled with helium. They can fly in the air. why they fly in the air, what is the reason behind it. In fact, if you will study closely, you will see the temperature linked to density, and that change in density ultimately causes it to float in the air. Or definitely, there's also another term appears which is called buoyancy. So again, if we have a good knowledge of thermodynamics, we can explore what can be the reason. Next, we know tornadoes are formed. Why tornadoes are formed? Tornadoes normally are formed because of the temperature difference, because of the density difference between those are thermodynamic properties. If we understand the formation of tornadoes in terms of thermodynamic principles, then might be we are able to predict, and if we are able to predict, then might be we can warn the people in advance, and we can go to safe places. So again, we can you can say answer these questions here very well if we are able to understand these phenomena using thermodynamic properties. So now you can see that we have wide range of application where thermodynamics can be applied in refrigerations, in aeroplanes, in power plants, even to human body, because human body have temperature, in the car engines, renewable energy, in the factories everywhere. So it's everywhere. So that's why it is a very fundamental subject, thermodynamics, which we need to know. So we can, being engineer, we can perform better in our daily, in our industries, and we can serve better. So I will close here with a question. We know, for example, we use refrigerator to cool down the water, drinks, and some other stuffs. But this is a question. If I open the door and I'm trying to cool down my room where I'm sitting using the refrigerator, it is possible or not? Thermodynamics. If we have good knowledge of thermodynamics, we have good knowledge of energy balance system, which is based on thermodynamics, then might be we can answer this question. So that's all from my side today. And this is, you can say, basic introduction to thermodynamics fundamentals, that why it is important to study thermodynamics. Next time we will start our regular lectures. And till then, bye bye. Have a nice day.